So this section is 10.6, and this is a section where we're going to learn about power theorems. So up until this point, we have only talked about angles and arcs and some relationships with the segments, but we didn't learn all the segment relationships with the circles. So that's what we're going to do today. There are three power theorems. The first one is called the chord-chord product. Chord product. And this one looks like you have two chords. One, two. We'll call this A, B, C, D, and E. And if you look at the two chords, once they intersect, they are now divided into two segments. So those two segments, when you multiply them, so chord AB is divided up into AE and EB. If you multiply them, that equals the other chord, the individual parts, CE and ED. So you could think of it like part 1 times part 2 equals part 1 times part 2 of the chord. So we're going to do our first example. First example, so a circle. We have 6, 8, x, and 5. Find x. For this problem, we would set it up 6 times 5 equals 8 times x. So x ends up being 15 over 4. The next example is a little more involved because that one was too easy. So we have an arc and a chord. And the perpendicular bisector, so perpendicular bisector is 8. And the length of this chord is 18. So a note, the perpendicular bisector of a chord does pass through the center. Now the question is this the center of the circle? Or is there a way to know? It is not the center of the circle, because if this is bisected, this is 9 and 9. If this were the center, then these would all be radii, and all the radii have to be congruent. So since they're not, this is not the center. So that means the center is somewhere, I don't know, like, let's say somewhere down here. Okay, so we're going to try to find the diagonal. I mean, not the diagonal, the diameter. There are two ways to do this problem. The first way, so you draw a circle. Let's draw the rest of the circle because this is a portion of it. This is 8 and 9 and 9. The center we'll say is here. So you could say that this is x, this is a right angle, this is a radius. The radius, since this is a center, is x plus 8. So we could do Pythagorean theorem, a squared plus b squared equals c squared. Solve for x that way. Another way we can do this problem is to use the chord-chord product, the power theorem that we just learned. That would mean that we would have to draw the rest of this chord. A diameter is a chord. There are two ways you can do this. You can keep this as x. So it's 9 times 9 equals x times, so this whole part right here, part 2, this is x plus 8, and that's 2x plus 8. So you could set it up that way. Or if you want to label part 2, all of part 2, its own variable, you could do that too. That could be, I don't know, let's say y. Then you would do 9 times 9 equals 8 times y. Find out what the whole diameter is, and then add it to 8, and then you'll get the diameter. Either way, there are multiple ways you can do this. The answer ends up being 18.125. The next power theorem is the secant secant. So the secant secant, we have a circle. If you remember, a secant intersects the circle at 2 points. So this, it would look something like this. We'll label this A, B, C, D, E. I like to call this like whole times outside equals whole times outside. So if we were to label it with the segments that we have, then it would be AC times, outside means the portion of the secant that's outside the circle. So BC. The whole secant is EC. The portion that's outside is DC. So we'll do our example for this power theorem. Okay. Secant. We'll label this X, 8, 7, and 9. We're going to find X. For this problem, the whole secant is X plus 8. The portion that's outside is 8. The whole secant of the second one is 16. The outside portion is 7. So X ends up being 6. The last power theorem is called the secant tangent. Secant tangent product. So we have a circle. A secant, again, hits the circle twice. A tangent intersects the circle once. So we'll label this A, B, C, D. And same thing, actually, whole times outside equals whole times outside. So the whole secant is AC. The portion outside is BC. The whole tangent is DC. The whole tangent is outside, so it's DC again. So I guess we could rewrite that as whole times outside equals tangent squared. Either way, whichever one is easiest for you to remember. So we'll do an example. We'll have our circle and O, this is circle O, so that means this is the center. Let me draw it this way and bring this out a little bit more. Okay, so this part is 8. This part is 20. This is R and R. we're going to find r. So the way we set this one up, the whole secant is 2r plus 8. The portion that's outside is 8 equals the tangent squared. We should get r equals 21. Let's do our one last one that's similar to the one we did earlier, because you're going to see this in your homework. I'm going to make sure we're good with this. Oh, actually no. We'll save that for later. So it's this arc with a chord. So the distance here is 2, and here to here is 7, perpendicular bisector. Find the diameter. So for this one, we can draw the rest of the circle. I already did that here. So we'll say this is 2, 3.5, 3.5. And find the center, draw a right triangle, call that x. A squared plus b squared equals, the radius is 2 plus x. 2 plus x squared. Again, we could also use the power theorem. We could do chord, 3.5 times 3.5 equals 2 times 2x plus 2. And of course, you can also set this whole, sorry, I didn't redraw this. Okay, you can set this whole thing to y and do 3.5 times 3.5 equals 2y, and then add it to get the diameter. Either way, the diameter ends up being 8.125. And that's it. All right, I'll see you later. Bye.